Okay, so to solve rational equations, the first step is factor the denominators to find the lowest common denominator. Sometimes you might want to try factoring the numerator if you think it's going to cancel out, but there's nothing really to do with the numerators here anyway. So let's factor those denominators. X minus 7 can't be factored, can it? 2 can't be factored. But the last denominator there, 2x minus 14, can be factored by taking out a 2. So it becomes 2 times x minus 7. And then we have to figure out what the lowest common denominator is going to be. That lowest common denominator is just 2 times x minus 7. And if this were an adding or subtracting question, then we would take each denominator and change it into 2 times x minus 7. But because it's solving, we go to step 2, which is multiply each term by the lowest common denominator. So we don't multiply by what's missing, we just multiply by that denominator. So we're going to go 2 times x minus 7 to that term, 2 times x minus 7 to that term, and 2 times x minus 7 to that term. And what happens then is some things will cancel out. So in the first one, the x minus 7 and the x minus 7 cancels out, and we're left with 2 times x squared plus 25. But there's no denominator anymore, or the denominator is 1. Because it canceled out, so now it's not rational anymore. The second one, the 2 will cancel out, so we have plus x minus 7 times x plus 5, and then equals, and in the last one the whole denominator cancels out, and so the numerator just stays the same, 2x squared minus 12x minus 9. So by multiplying each term by the common denominator, it cancels out the denominators and leaves us with something we already know how to solve, because it's either going to be linear or quadratic in all the questions that I ask you to do. And that's going to be your strategy whenever you're working with an equation with fractions, is multiply through by the common denominator. It gets rid of the fractions and makes it something easier to solve. So now the third step, expand, simplify, and solve. This will become 2x squared plus 50 plus x squared minus 2x minus 35. So what I'm doing is expanding, right? 2 times x squared, 2 times 25, and then we go x times x, x times 5, x times, or negative 7 times x, and negative 7 times 5. Move that out of the way. Equals 2x squared minus 12x minus 9. So because it's quadratic, we want everything on one side of the equal sign. And combine like terms. Right now we have 3x squared here and here. That's 3x squared, and we'll subtract 2x squared. So we'll have x squared. And then combine the x's. We have negative 2x and plus 12x. So plus 10x. And then the numbers, 50 minus 35. So 15. And then plus 9. So we get to this quadratic, x squared plus 10x plus 24 equals 0, and then factor that to solve. X plus 6 times x plus 4, which means x equals negative 6, and x equals -4. The last step is to check solutions for non-permissible values and extraneous solutions. The non-permissible values in this one would be x cannot equal 7, right? So that actually tells me that there are no extraneous solutions here because the solutions are -6 and -4, and that's okay. The problem would be if I got a solution of x equals 7 and my non-permissible value was x equals 7, then that would cause an extraneous solution. But these are fine. I should still check and make sure that they work just by filling them into the original. That 2 is actually over 1. So what's the common denominator? Just x minus 4. Looks like most of you were able to get this one. What you're going to do is multiply each term by x minus 4. The only thing, some people did x minus 4 over x minus 4, which is not right. Just x minus 4. But what happens when you do that, those cancel out, so we have just 5x for that first term. The second one is 2 times x minus 4. And then the x minus 4's cancel in the last one as well, so it's 3x minus 8. So this becomes 5x plus 2x minus 8 equals 3x minus 8. So if we move all of the x's together, there's 7, and then subtract 3x to move this one over here. So 7x minus 3x is 4x. And then we'll add 8 to both sides. 4x equals 0, so x equals 0. The non-permissible value is 4. X cannot equal 4, but x doesn't equal 4, so we're good. Check just by filling it in, and you'll find out pretty quickly that it works. Each side, it comes out to 2 equals 2. So here's my solution to the last one. I factored the denominator of the third term to get x plus 2, x minus 3, and then multiplied each term by x plus 2 times x minus 3. It's simplified to 3x times x minus 3 minus 5 times x plus 2 equals -25. Expand and simplify, you have a quadratic. When you factor it, you get your two factors at the bottom, 3x minus 5 and x minus 3, and that gives you the two solutions. X equals 5 over 3 and x equals 3. There is a problem with my solutions though. What is it? One of the solutions is one of the non-permissible values. So if we look at the non-permissible values, we know x cannot equal -2 and x cannot equal 3, and yet at the end we got x equals 3. So we're going to reject that. That's an extraneous solution, and the answer is just x equals 5 over 3. So there's only one solution, because the other one is one of the non-permissible values. And the fact that it's a non-permissible value trumps the fact that we got it as a solution. Basically what it means is that x equals 3, it's a solution to actually any of these ones. So it's a solution at this point. If you were to fill it in here, it would be fine. Or here, or here, or here. But it's not a solution up here where they are fractions. Which means it's not a solution to the original problem. So we reject it as an extraneous solution.